Hello, this is the video presentation for Team 6, Team Enigma, as part of the project deliverable 5 assignments for CS445 software engineering with Dr. Wee Sim. My name is Asaf Ahmed, and I'll be giving you an overview of the application. So the project description, let's talk about that. The name of our application is the Modern Enigma. The application allows user to encrypt and decrypt text with ease. Users are able to enter their desired text, select a cipher type, select a key value, and the application allows users to select from different ciphers, such as the affine cipher, the auto key cipher, the shift cipher, and the beginner cipher. On to the next part. So the development platform we used was NetBeans. To develop this application, the version of NetBeans which was used was 8.2, Integrated Development Environment, or IDE. In NetBeans, we took advantage of the Java FX platform in order to create a graphic user interface, or GUI for short. Developing a GUI was a huge priority for us because we wanted to make this application as simple and user-friendly as possible. And let's talk about use case diagram. So here's an overview of how actually our application works, as you can see, featuring our use case diagram. So there are two actors for this application, which are users and algorithm. Users can perform two different actions. They can they can either encrypt text or decrypt text. As part of our encrypt text use case, users can enter a plain text value and select a cipher type, enter a key value. For the decrypt text use case, a user can enter a ciphertext value, select a cipher type, and enter a key value. The algorithm can encrypt text and decrypt text.
Hello, my name is Ashwant, and I'll be talking about how our application works and how that is reflected on the pages of our graphic interface. The first screen shown on the left of our home page or opening page. This first screen, as a user, you'll be when open the application. By clicking the start button, indicated the smaller arrow that will take into selection page shown on the right, where they can decide whether they would like to have an encrypt text or a decrypt text. The selection on this page determines which sequence of diagram is active. If user selects the encrypt button on the previous page, they will be taken to the encryption page. At this point, the encrypt text use case begins. On this page, there is a text fields where a user can input a plain text value and a ciphertext. Once the cipher type is selected, the user can input corresponding key values. The diagram uses reference fields for inputting a plain text, ciphertext, and a key, which used to simplify diagrams and increases the readability. The use case for these fields will be on the preceding slide. These are the use case reference fields. When the sequence reaches the input plain text reference field, the sequence on the left-hand side is activated. When the sequence reaches the select ciphertext, the reference field sequence on the middle is activated. Sample principal applies input key value as a reference field. If the user has selected decrypt button on the selection page, they will be taken to the decryption page and the decryption text use case would begin. On this page in your application, user can input a ciphertext and desired cipher type. Once the cipher type is selected, they can be taken to the key value. These are the reference fields for the decryption use case. The same principle as with the encrypt applies to this. When this sequence reaches to the input ciphertext reference field, the sequence on the left hand side is activated. When the sequence reaches the select cipher type reference field, the sequence in the middle is activated, and so on.
Hello, my name is Jack, and I'll be talking about some of the features of our application. So there are a few interesting features that we implemented in this application. The first is the input validation on text fields. This is one of our main priorities. Input validation is necessary to ensure that users cannot input data which could potentially break our application or cause it to not function properly. Obviously something that we would not want. So we implemented validation techniques on each of our input fields to stop that from being a possibility. Another feature we wanted to mention was the availability of different cipher types. So we really wanted to give the users as many options as possible to choose from, as opposed to just one. So we designed more than one algorithm for encryption and decryption with 4 different algorithms for a total of 8. Lastly, and this may seem like common sense, but another feature we'd like to highlight is our GUI. So as mentioned previously, developing a GUI was a huge priority to us because we wanted to make this application as accessible and as user-friendly as possible. So if a user were to have to type their inputs into an IDE and execute the application that way, that may deter them from using the application, which is obviously something that we would not want. So to expand on the input validation topic we just discussed, we wanted to discuss what sorts of inputs we validated. So as mentioned previously, input validation was implemented on every text field. For the plain text and ciphertext values, our application evaluates the length of the string that is input by the user. We did not implement any sort of validation to the cipher types because we chose to use a drop-down list where the user can select their desired option. There is no sort of actual input to test. For the key values, we tested based on what key value each required. So if the cipher type required an integer value, for example, we checked to ensure that the integer was in a valid range. If the key value was a string, though, we would check to see if it was a valid length. And in order to ensure that our input validation functioned properly, we tested all our inputs based on values which we determined when conducting our black box testing earlier. So here we have screenshots from our black box testing with plain text length, ciphertext length, and of the key values for a cipher. So for the plain text and ciphertext length, we had valid input lengths which were between 1 and 20 characters. So we tested the values 1 and 20 to ensure that those and any values in between would be valid. We also tested values 0 and 21 to ensure that they would spit out an error since they're outside of the valid range that we specified. This key value input validation was conducted on all the key value inputs. And to see all of our results, please go back and refer to our project deliverable 4 document.
Hi, my name is Jennifer Tenholder, and I'm going to be walking you through a demonstration of our application. As my teammates have explained previously, what our application does is it takes textual input from a user, then encrypts or decrypts it depending on what the user would like, using a variety of different cipher types. So within our application, we have 4 cipher types available. That is the affine cipher, the auto key cipher, the shift cipher, and the Vigenère cipher. And in this demo, we are going to be showing you the functionality within all of those ciphers. So when you first start the application, the user will be prompted with this screen. So it just has our team name, our application logo, a slogan, and then a start button. Once you hit the start button, you'll be taken to a selection stage where you can select if you'd like to encrypt or decrypt text. We're going to start by selecting encrypt, but we will show the decrypt functionality as well. So on the encryption page, the user is prompted to enter a plain text value as well as select a cipher type. So for this example, we are going to use software engineering as our plain text value. And then we're going to select our cipher type. And then depending on whatever cipher type the user selects, a certain amount of text field inputs will be shown below. So the affine cipher accepts 2 key values that are integers. So there are 2 text fields below. So we are going to use 11 and 7 for our key values, hit submit on both of those, and we are given our cipher text, encrypted using these 2 key values. Then to show that this function works, we are going to copy the ciphertext and paste it into the decryption function for the affine cipher. Because if this function worked correctly, by decrypting it, we should get this original plain text. So copy, and then we are going to run the application again. So we're going to start, decrypt, paste that ciphertext value in, submit that, select the affine cipher, submit, and again, we are prompted with 2 text fields because the affine cipher uses 2 key values. So with the affine cipher, the first key value is going to be the multiplicative inverse of whatever value was used to encrypt it. So the multiplicative inverse of 11 is 19, so we are going to input that value. And then the second value just stays the same, so it will be 7. And by doing this, we get our original plain text, which is software engineering. So that is the functionality for the affine cipher. And now we're going to show the functionality of the AutoKey cipher. We're going to start by encrypting. We're going to enter our plain text value, which again will be software engineering. Submit that. Select the AutoKey cipher, submit. And the AutoKey accepts 1 key value that's an integer, so we only have 1 text field that only accepts integers. So for this example, we're going to use 10 as our key value, submit, and we get our cipher type. So now we are going to go and paste this in the decryption function just to make sure we get the same value. Start, decrypt, paste that ciphertext value in, select the AutoKey cipher, and input 10, submit, and we get that original plain text, software engineering. So next, I'm going to show you the shift cipher. So again, let me start the application. Start, encrypt, again, software engineering, submit, drop down shift cipher. And then the shift cipher accepts 1 key value that's an integer. So we have 1 text field that accepts only integers. For this example, we are going to use 3 as our key value. We are given this as our cipher type. Going to copy that. And then we're going to start the decryption function, paste in that ciphertext, submit, shift cipher, submit, key value 3, submit, and we get that original plain text of software engineering. Then the last function I'm going to show is the Vigenère cipher. So let me start up the application again. Hit start, encrypt, software engineering, submit the Vigenère cipher. And then for the Vigenère cipher, the key value that it accepts is a string. So we're going to enter Java, and we get our ciphertext. Copy that. And then we are going to run the application one more time. Start, decrypt, paste in that ciphertext, submit, select the cipher type as Vigenère cipher, submit, and then enter our keyword or key value again. Java, submit, and we have our original plain text, software engineering. Another functionality I did want to point out on our application was our error checking. So I'm going to show you this using the encryption page with the affine cipher. But error checking has been implemented on all text fields within our application. So input validation is important because we don't want any users inputting values that could potentially damage our application and affect its functionality. So we decided to make sure that user input is valid before allowing our application to attempt to process it. So for the plain text field, as well as the ciphertext text field, users can only input alphabetic characters between 1 and 20 characters. So what happens if they do not follow that rule? Let's say they enter A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, Z. That should be 26 characters, which is 6 characters above our 20 character limit. As you can see, an error message is generated and that text is cleared from the field so they can't repetitively try and submit it and possibly break our application. So when we open up the key values, there is also limitations on the range of key values that someone can input. So for key values, a user can input values between 0 and 25. So what happens if a user were to try and hit a negative number? An error would be generated and the text field would be cleared so they could not just repeatedly spam click that submit button. And then what if we go above 25? Let's say we go 30. What's going to happen then? Another error message has been generated and that text has been cleared from the text field. Although we are currently satisfied with the appearance and the performance of our application, we do want to acknowledge that there are areas where we could improve or enhance in the future. The first area is our graphic user interface. We are satisfied with the features and performance of the JavaFX component of NetBeans, but we'd love to be able to build out the GUI more with a device emulator and design software such as Android Studio. We would also love to add more ciphers for users to select from. In our application, we have those 4 we've talked about previously, the affine cipher, the auto key cipher, the shift cipher, and the Vigenère cipher, but there's hundreds of others out there. There's a permutation cipher, there's substitution ciphers, there's RSA, and so many more, and we'd love to make those available for users. And lastly, we would love to add some sort of additional page which shows users how their text is being encrypted and decrypted with these ciphers so that our application could be used as more of an educational tool as well. So this has been Team 6, Team Enigma, presenting our software application, the Modern Enigma. We've worked very hard on the software application over the course of the semester, and we hope you like it. If you have any questions, please refer to our SRS document.